GeoGebra Classic to try this problem. Now it says the function is, so we'll call it f of x. Oops, f of x is 1/2 to the minus x power. All right, so then the first thing it does is it says we want to reflect it around the y-axis. Now to reflect it around the y-axis, I'm going to create a new function that is f of minus x, like this. So that reflects it around the y-axis. Notice that it becomes 1/2 to the minus or plus x, right? Now, the next thing is I want to compress it by 1/5. So I'm going to take the function I just had, and I'm going to multiply it by 1/5. Oops, got to get a real x in there. And then I have my function. Notice that here, this goes down to 2/5, so it's being squished out. And there we go. We have our function that looks something like that. Notice you can always tell if it's increasing, your function is going to the goes to the, it has a horizontal asymptote going to negative infinity. If it's decreasing, it's going to infinity. So since the first one was, why is f increasing? F should be decreasing. F to the minus. Oh, yeah. This is a really weird function now that I look at it, because this is really just 2 to the x. Weird. We have our function that we start with is f of x. Oops. F of x equals 1.68 to the x power. Now it says shift it to the right, so we're going to take that function, we'll create a new one by shifting it to the right, which means that inside the parentheses we move it by 3, so we move it over 3 units. Notice that how this function is changing, where the minus 3 goes from, we're putting inside is in the exponent here. Now we want to stretch it up, expand it by 2. So 2 times g of x. And now we want to flip it around the y-axis, or the x-axis, sorry. So that would be, say we'll call it k, would be minus h of x. And now it says move it down by 3, so I'm going to take p of x, set it equal to k of x, and then subtract 3 off of it, and we get our function like that. And it builds, see, even GeoGebra builds our function flow, so this is the actual function that we just created. It looks something like that. And you can tell the asymptotes here, they're always kind of the key. They're staying at 0 until we do this last one, where that's when we shift it down. Okay, so let's see if we can distinguish which ones each one of these are. So notice here that all of these go through a single point, and 2 of them go through a single point. Now these guys, because they're smaller, if I plug in 0, I get out that point. Well, notice that I have then all of these right here, because they go through 2, those are these points, and then the other 2 are these guys here, because they go through at 4. So already I know that 16 and 18 are C and D. So which are which? Well, if it's increasing, then the number that is my base is bigger than 1. So D is increasing, so this one would be D. And this one is D. This is decay, so this would be, the other one's growth, this one's decay, and this is less than 1, so this would be C. Now, if I look at the other ones, notice that I have 2 that are growth and 2 that are decay. So these 2 are the growth ones, so all I have to do is know which one is which. So so if I go over here at, say, 1, I would know that the bigger number is going to be the one that's above. So the bigger of 1.28 and 1.59 is E. The smaller is F. And then if I take these two, their decay, so if I go over here a little bit, like if I pretend like this is 1, this would be the, with the smaller fraction, or the larger fraction of this would be the smaller fraction, so this one would be B, and this one would be A, like that. Alright, so now this is 2 to the x, so they tell us this much, which is kind of cool. So that means that I want to know what the equation would be. So I can tell by looking at it that I have an asymptote that's equal to 3. So I know that I'm going to be adding 3 to whatever my function is. Well, this thing right here. Now what I also know is it's been flipped around, so I'm going to multiply it by a negative. Alright, so if I take, let's see if this is going to get us everything we need. So if I take negative 2x, so this would be at, if I just did the 2x here, it would go through these 2 points and have an asymptote that goes this way. So if I flip it around, this would go to negative 1 if I multiply by negative, and this would go to negative 2. Now if I add 3 to both of them, this one would go up 1, 2, 3, which is where it is, and this would go up 1, 2, 3, which is where it is. So I think we have our function here, which is y, or f of x, is equal to minus 2 to the x plus 3.